Okay, today we're going to look at synthetic division. Synthetic division is a way of dividing a problem out in a much shorter way. We call it shorthand division because you don't have to keep up with the letters, you're just keeping up with numbers. And another thing is that it does not take and get really lopsided like long division does. It basically stays very straight across the bottom, and it's pretty simple. Step 1 is to take your divisor and find the zero of the function. The zero of the function of this problem is x equals 1. Instead of making a long division box over your problem, you put that in a short box so that it's around your divisor instead of around your dividend. Then the second part is to take the coefficients off your problem and make sure you have all your terms from the highest power down. So my highest power is cubed, so there's a 1 on that. There's a squared term, it's quadratic. There's a linear term, it's -1. There's a constant, it's -3. Another thing that's different about this long division is I don't have to figure out how many times it goes. That's a long division thought. Synthetic division is a lot simpler than that. And also, where in long division you have to change the signs and add on every multiplication process all the way through, changing the signs for the zero of the function makes it add all the way through, and we're not changing any more signs. We change one sign and it does multiply and add all the way through, and not multiply, change the signs and add. To get started, you bring the first number down because you need something down here below the line in order to have something to multiply and add. So we multiply to the box, and put in the next column. So 1 times 1 is 1, and then you add up that column because you don't need to change the signs and add. We've already changed one sign, the zero of the function, and that takes care of that. And that adds up to 4. And then you multiply to the box, and that makes 4. And then you add this column up, which means subtract and take the sign of the largest, which is 3. And 3 times 1 is 3. That adds up to 0. Now, if you go back and think about just dividing the first term by the first term, x cubed divided by x will be x squared. So this will start with x squared, then go to linear, then go to constant, and that is your remainder. And your remainder is always the last number on the bottom row. So this one doesn't have a remainder. So this is my answer to this question. Let's try another one. So in this one, what would go in our box? Well, you're supposed to set the divisor equal to 0 and find the zero of the function, which would be -4. So we put -4 in the box. Then we put our coefficients down. We got a cubic, a quadratic, a linear, and a constant. 1, -7, -7. I think that's 20. All right. Bring down the first term and multiply and add. Multiply to the box makes -4. Add it up makes -11. Multiply to the box makes 44. Add it up, makes 37. Multiply to the box, let's see, that'll be 8 carry a 2, 148, -148. So add that up, make a -128. Now, to put our powers back, if this is our remainder over our divisor, another way of putting your powers back is to start from that end and think, okay, this will be a constant, linear, quadratic. Or you can say x goes in x cubed, x squared times, telling you to start with an x squared. Now, how do I know this is even right? Well, let's look at it. There's a thing called the remainder theorem. And in the remainder theorem, you can check to see what the remainder is going to be before you work a question. For example, this divisor has x equals 5 is a zero of the function. If I put that in my calculator, I should be able to calculate up what my remainder is so I can see if my remainder is correct. Now, it won't tell you if you've got all your terms right, but it will tell you if your remainder is correct. So 5 stored in X. Well, hold on, it didn't take 5. 5 store X. Then you type the original problem's dividend. This one's 4x squared minus 16x plus 9. 4x squared minus 16x plus 9. That tells me the answer to this question is going to have a remainder of 29. So my remainder is equal to 29. So let's use this to go back and check our last problem. So in our last problem, the remainder came out negative 128. So let's check and see if that's right. So first we have negative 4 to store. Negative 4 store X. Then we got to type the problem. X to the third minus 7x to the second minus 7x. I'm all up in the power, so I got to fix that. I keep forgetting to get out of the power. Minus 7x squared minus 7x plus 20. And it tells me my remainder was supposed to be negative 128, like I said. So I now know this problem is right because I got them negative 128. So that's how you can check and see if you've done your division correctly. So that's what the remainder theorem is all about. It gives you an opportunity to get the remainder. So in question number 3, first of all, the zero of the function is going to be x equals 1. So we're going to check the remainder before we start. X cubed minus 2x squared plus 6. All right. So one thing we want to do is 1 stored in x. X cubed plus x squared. I don't know if that's right or not. Hold on, let's go back and look at the question. No, minus 2x squared. Minus insert 2 x squared plus 6. So I now know that the remainder of this question is 5. When I finish the question, if I don't get 5, I know I've got the wrong answer. So I start with a cubic, so I'm going to have a quadratic, linear, and a constant. There's a 1 for the cubic, a negative 2 for the quadratic. There is no linear in this problem, so you have to fill in a 0 term, just like in the other process, and 6 for the constant. Again, you bring it down. Instead of putting it on the top like you do how many times it goes on the top of long division, in synthetic division, you don't figure out how many times it goes. You bring the first number down and you start multiplying and adding. So 1 times 1 is 1, and that adds up to negative 1. 1 times negative 1 is negative 1, and that adds up to negative 1. And 1 times 1 is negative 1, and that adds up to 5. See, I got that remainder I said I was going to get. This is a constant, linear, quadratic. So once you write your remainder, you just back up with powers, or you look at the powers always going to go down by 1. So since I started with a cubic, it's going to go down to quadratic because it always goes down by 1 because you're dividing by 1x. Let's look at this one because I want to look at one that has a number in front of x because that's a little different. So in this problem, if I solve this equal to 0, I would have to subtract 7 and divide by 2, and that would give me my 0 of the function. So negative 7 over 2 in the box. And then I have a quadratic, a linear, and a constant, so this is a little shorter question. I only have 3 numbers to work with. When I bring my first number down, I have to do negative 7 halves times 2. So put the 2 over 1, cancel those 2's, and that makes negative 7. Then you add that column and get negative 6. Then you do negative 7 over 2 times negative 6 over 1. 2 goes into 6 3 times. 2 negatives multiply to be a positive, and 7 times 3 is 21. And that gives me a remainder of 1. Now I could go and check that, but I know that's the remainder. But if I just started dividing the problem to see kind of what it would do, if I took these two and divided it, 2x squared divided by 2x, the x2's would cancel and give me x. Yet here it starts with a 2. So there's something wrong here because the problem isn't starting with a 1x like it should if I just divided the first two terms out to see what it's going to be. This is a byproduct of synthetic division. A byproduct means that it did something that you weren't expecting, and that was caused by this fraction. This fraction says -7 divided by 2. So what it did, and we don't know exactly kind of where this goes, but if you just bring a 2 down in this problem, it doesn't divide the 2 by the 2 by doing that. Even though I canceled these two 2's out because that 2's already written down, it didn't get divided by 2 in the math process on the first number. And so we have to go back and divide these by the number in front of x to get x minus 3 plus 1 over 2x plus 7. You don't divide the remainder. The remainder always comes out correct. But you have to divide all the other terms because they are affected by me bringing this 2 down. And that first number didn't get divided by 2. So therefore, none of them got divided by 2. And we have to go back and divide them by 2 except for the remainder. Let's do one more like that. In this problem, if I take and add 2 and divide by 2, I get 1. Yet this problem starts with a number in front of x, and it came out a whole number, so that's good. At least there's not going to be a fraction in our box. But also this problem's not in order. The cubic is 4. The quadratic is -2. The linear is 4. The constant is -14. So let's divide this out and see what we get. So I bring my 4 down. 4 times 1 is 4, and that adds up to 2. 2 times 1 is 2, that adds up to 6. 6 times 1 is 6, and that adds up to -8. And as you see again, if I divided 2 into 4, it would go 2 times. But it ends up with a 4 in front instead of being a 2. So I got to divide everybody by 2. Even if that box isn't a fraction, if there's a number in front of x, you have got to divide by it. So that makes it from cubic, it goes down to quadratic, linear, constant, and you don't divide your remainder by it. Although in this particular case, if I was working this question on a standardized test, that would probably need some work, because if you took a 2 out of the bottom, this 2 would cancel into that 8 4 times. So it's possible that if you could take something out of the divisor, it also would divide into the remainder. But I'm not going to really focus on that right now because that's really part of the next lesson. But this particular one did do that. So synthetic division is not difficult. You can check your synthetic division really easily and be able to get your remainder checked to know if the whole problem is right. Because you can't work a problem correctly and get the wrong remainder. And you can't get the correct remainder and will have worked the problem wrong either. So if the remainder's right, the whole thing is right, except for putting the x's back on. Some students do mess that up, but it's not very difficult. So I hope this helps you with finishing your homework.